obviously spent a chapter in Algebra 2 doing sequences and summations. Sequences and series, really. So sequences are just the list of numbers, and series or summations is when you add all of those numbers in that list together. So you spend a chapter on this in Algebra 2. We touch on it again this year. You use it again in BC next year. So just kind of getting our feet wet and reminding you what this was all about. Writing the first four terms of the sequence, a sub n equals this whole bit here. So a sub n just gives you the whatever term you're on. So a sub 1 would be the first term, a sub 2 would be the second term, and so on. So if we want the first term, you would just plug in 1 for n. Which would be negative 1 over second term, plug in 2 for n. Just be careful of your negative being squared here. That's going to be a 1 over 8. Sub 3. It's going to be negative 1 over 26. And a sub 4. Again, careful of your negative base being raised to an even number. It's going to be 1 over 80. Jalen? So that's just a straightforward rule, just plug in your numbers. The second exercise wants you to write the first four terms of this sequence in which a sub 1 equals 5 and a sub n equals 3 times a sub n minus 1 plus 2. Now, these are different types of sequences, and I wrote them below here. The first one is an explicit. An explicit just means if you want the 100th term, plug in 100. Recursive, on the other hand, which is what this second sequence is, if you wanted the 100th term, you would need to know the 99th, right? So explicits are nice because we get right to the point. We can just plug in the 100 and get the term. Recursives can be a bit annoying depending on what number term you're asked for. So this section here, a sub minus 1, to me, if a sub n is the term you're looking for, a sub n minus 1 is always the term before. If it was a with a subscript of n minus 2, that would mean 2 terms before, and so on. So for this one, I almost, if I'm looking for the second term, for example, I already know the first term is 5. If I want the second term, you can plug in 2. But mentally, if you plug in 2, 2 minus 1 is going to be just 1, so it'll just be 3 times a 1, which is the term before, and then add 2, which is 3 times the 5 plus the 2, which is 17. And then if you want a sub 3, you take 3 times the term before. What was the term before? 17, and add 2. 53. And then for the fourth term, we do 3 times the prior term, which was 53, and then add 2. 160. And there are our first 4 terms. Liam?
Isn't there some way to turn recursive into explicit?
Not all recursives, but some, yes. Like if the recursive pattern is arithmetic, which we'll get to, like adding the same thing every time. Is this one arithmetic? Are we adding the same thing every time? No. Is it geometric? Are we multiplying by the same thing every time? No. So this one, it would be tough to turn into an explicit, if not impossible. But for arithmetic ones and geometric ones, yes. When there's that defined pattern, you can. Okay. So just know vocab words. This one explicit next to it, and this one recursive. Okay, factorials. Raise your hand if you know what that 7 with an exclamation point means. 3 of you. Raise your hand if you feel like you've seen it before, remember it. Raise your hand if you feel like you've never seen this before. Because I don't really know if and when you'd ever see that symbol. I used to do it in, I feel like, pre-algebra, like probability type stuff. Factorial means that you start with that number, in this case 7, and you then multiply by every integer prior to it all the way down to 1. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. You're going to need your calculators for at least this one. This is more to illustrate what that symbol factorial, and you would read that 7 factorial, but yes, it's an exclamation point. 7 factorial. And on your calculators under the probability menu, so math, and then if you scroll over to PRB, option 4 has the exclamation point button. So I probably should have typed in the 7 first. 7 exclamation, 7 factorial, and it will do it all for you. 7 times 6 times 5 times 4 times 3 times 2 times 1. If I did it manually, I obviously get the same thing, but that's 5,040. So it's math, and then scroll over to PRB for probability, and then grab option 4, I think it was, for the exclamation point. Liam. You are, because this is what you're going to more be using it for, and understanding how am I supposed to do B without a calculator. And if you think about the meaning of factorial, the numerator is 10 times 9 times 8 times 7 times ... all the way down to times 1. Your denominator is 2 times 1 times 8 times 7 times 6 times ... all the way down to 1. So what nice thing happens here? Right. The 8 and down cancels with the 8 and down here. So we really end up with 90 over 2. Can you do that in your head? 45. So, you know, using your knowledge of what this all means to find shortcuts. And then C is a little bit tricky because now we're dealing with variables. So Adam, what would the numerator mean here? Someone help him out from here. Liam? Right, you're multiplying by 1 less than the previous, right? So 1 less than n plus 1 is n. 1 less than n is n minus 1. 1 less than n minus 1 is n minus 2, and so on. You don't know n, so you don't know how long this is going to continue, but you do know it's going to go all the way down to 1. Does that make sense, Adam?
Yeah.
Good. And then on the denominator, you just have n factorial, so you've got n times n minus 1 times n minus 2, ... times 1. And so that beautiful thing happens here as well. N and down cancels with n and down, and the answer is just n plus 1. Okay, so when you come across those on your homework, just being creative and kind of figuring out what cancels so that, yeah, you will be able to do this without a calculator. There may be a couple on your homework that are straightforward, like 7 factorial. Go ahead and use a calculator. But like on a test quiz, I'm going to put something that can be you can figure out how to manipulate and simplify. All right, and then a sequence. This one is an explicit sequence, but using a factorial symbol. So a sub 1 is going to be 2 to the first over 1 minus 1 factorial, which we have to talk about. Because 0 factorial has a special rule, like raising something to the 0 exponent has a special rule, because you can't think about it literally the way it's meant to be thought about. Like, you can't 0 times everything underneath it down to 1, because that just doesn't make any sense. Any guesses? 0 factorial. Any guesses? Yes. So 0 factorial, kind of a special circumstance to know just on the side that it equals 1. So you might have thought before I just told you that oh, seems like it's probably going to be undefined because we have a 0 in the denominator, but you don't. So it's 2 over 1, which is just 2 for the first term. And then we shouldn't have that problem again. A sub 2 is 2 squared over 2 minus 1 factorial. But just like order of operations, we're going to do the parentheses first. So it'll be 4 over 1 factorial, and 1 factorial is just 1 as well. This is Grizanti. This would just be 4. The third term, a sub 3, is going to be 8 over 2 factorial. What's 2 factorial? 2. So 8 divided by 2 is 4. And then lastly, our fourth term, we get 16 over 3 factorial, and 3 factorial is 6. This one just can be reduced to 8/3. So new symbol, new math symbol in your life. Not difficult, just new. And this you remember, correct? And I know you guys probably did a lot of this on the calculator last year. We will be doing this year. But there's obviously more efficient ways. No one is going to make you plug in a 4 all the way up to 100, right? And if that ever is called for, there's got to be a faster, more efficient way to do it using sequences and series. So we'll explore all that. But just to remind ourselves what the procedure was, you plug in 4 to get your fourth term. Well, yeah, it's technically your first term because the sequence is starting with a 4. But you're going to plug in a 4, get a number, plug in a 5, get a number, plug in a 6, get a number, all the way up to 7, get a number, and they all get added together. This is a summation symbol. Sigma notation, but sigma in this context in math means summation. So when you plug in your 4, you're going to get 16 minus 5, 11. When you plug in your 5, what's that? Very good. Again, careful of your negative base here. Being raised to even versus odd exponents messes with it quite a bit. The 6, 64 minus 5 is 59. And negative 2 to the 7th will be negative 128 minus 5. Correct, negative 133. And then because of that summation symbol, we are adding all of these together. So I would be inclined to combine my positives first. So 59 and 11 is 70 minus 133 and 37 combined to be 170 minus 170, which is just negative 100. Any questions there? B is a little maybe confusing because why? There's no variable. So when you go to plug in starting with 1 and plugging in everything up to 5, when you plug in a 1 to this expression, what's the value of the expression? 3. And then when you plug in a 2 to this expression, what's the value? 3. And then a 3 is 3, and a 4 is 3, and a 5 is 3. So no matter what you plug in, you're going to get a 3. And then you're plugging it in 5 times, 1 to 5. And so you get 15. So just be aware of how to handle that when your expression is a constant. And then this kind of taking a sequence and going backwards, figuring out what the summation would have looked like to make this happen. So, what do they call this? The index variable. Can be k, can be I, can be j. It's just really a variable. I'll stick with k. So thinking about what do we start by plugging in, and we plug in all the way up to what number, and then what's the expression we're plugging into? Who thinks that they can? Let me give you 30 seconds to kind of play with it on your own, then I'll call on someone. Michelle, what do you think? No idea? All right, well, let me help you kind of think through it. What about each term of this summation is staying the same? Okay, so something is being raised to the third power. Is that fair? Every single term. So starting with what number? What's being raised to the third power first? 1. And we're going to keep doing that all the way up until 7. And so this is what's changing. So this is where your variable comes in. So if you think about that, you'd plug in 1, you'd have 1 to the third. Then you'd plug in 2, you'd have 2 to the third. Then you'd plug in 3, all the way up to 7. Does this make sense? Any questions on that? Okay. And then take a minute to try to think about B. And if you're feeling stuck, think about what's staying the same, what's changing, how's it changing, and wrap a variable up in that portion. Stephanie, I want to talk to you. If you were able to get the whole thing, give me the entire thing that you got. If not, just give me different portions that you got. One over something, but we're not sure what. And we don't know what it goes up to. Right? So let's look at all the denominators. What do you notice about the denominators? Not just multiples of 3, but powers of 3, right? Because if they were multiples of 3, it'd be 3, 6, 9, 12, 15. We're talking powers of 3. This is 3 to the first power. 9 is 3 to the second power, right? So it's always 3, that's another consistent thing, to some power. Yes? So, but how do you explain this first term? This is 3 to what power? The 0. And then 3 to the first, 3 to the second, 3 to the third. So what's actually changing is this exponent. So I'll put k, 3 to the k. But k is now not starting with 1. You just kind of pointed that out. What's it starting with? 0. And what's it going up to? What's the highest k exponent that this ends with? Well, it's just going to be n minus 1. The last variable that the last thing that they plug in that variable spot is n minus 1. Josh. Hold on. Up to n. Okay, so let's see. If he plugs in 1, he's going to get 1 over 3 to the 0 power, which is 1. Okay, that works. If he plugs in 2, he's going to get 1 over 3 to the 2 minus 1 is 3 to the first power. He'll get 1/3 as his second. Perfect. If he plugs in 3, he's going to get 3 minus 1 is 2. 1 over 3 is perfect. 1/9. And then the last term he would plug in, we can jump, if the first few work, that's great. Then let's just go to the last one. If he plugs in an n, he'll get 1 over 3 to the n minus 1. Does that work? Yes. So what do we realize? There are multiple ways of writing the same thing. Liam.
For the very first term of the one you gave.
This one here?
Yeah, if you did k equals 0 in that, then it would be 0 minus 1. It would be 1 over.
In this one?
Yours.
This one.
It would. Oh wait. Never mind. Sorry.
Yeah, if you plug in the 0, you're fine. And then when you plug in the n minus. Yep. Anything else? Did anyone do it a different way? Yeah. Hold on. Say that one more time. Yep. Negative m? Okay. That's okay. Well, I need an n in there. This is fine. This is good because that's exactly, because this is 3 to the negative first, 3 to the negative second, 3 to the negative third. Wouldn't that be n? Something's not right with that n. I think it would have to be n negative n plus 1. No. I think it would still just be n minus 1. I don't know, I gotta think this through. It's definitely not n, because if I plugged in n, it would be 3 to the negative n, which would be 1 over 3 to the n, right? I want it to be 3 to the n minus 1, so I think I could just do n minus 1, because, right, 3 to the negative n minus 1 power will become 1 over 3 to the positive n minus 1 power. So I like it. It's a third way, but we just had to mess with that. We had to think a little bit harder there, I guess. But just exactly what you said, just to the n minus 1. Okie doke? So whatever variable is in here that you use here is the variable that should be wrapped up in here. Don't let the fact that they end with a different variable really throw you. Although it does get can get a little confusing. Good. Okay. All right. So why don't we? Your homework's there at the bottom. I wanted you to have a little more practice on a certain type of these than others. So in certain sections, I want you to do all of the odds. So pay attention to that.
Is it still in that book?
Yep. We're in this book for one more chapter. This is the last chapter, and then we'll swap out. And then I'm not going to let you go anywhere with your midterms, but I want you to see your midterms for the next 8 minutes. But I'm going to need, so you can have as much time with them, I'm going to need assistance. So, what? Oh yeah, Liz is in here. Anna Fox is not ring. Anna Jack. Through. Can you pass those out? Can you pass these out? Adam. And Josh, Kristen,
I'll pass it.
Hunter, Adam.
I'm in a good mood today.
Thank you. You're in a good mood?
Yeah.
Hmm.